All right, let's dive right in. Today, we are going under the hood, so to speak, to look at a piece of technology that's absolutely everywhere, yet almost completely hidden from view. It's this mechanical marvel that, well, it quietly makes our modern world literally turn.
So let me start by asking you a question. Just think about it for a second. A helicopter's rotors spinning, the crazy precise arm of a factory robot, the wheels on your car. What is the one mechanical secret they all share to get their job done? Just keep that question in the back of your mind, because the answer is surprisingly elegant.
Okay, so here's our game plan. We're going to start by revealing this hidden hero. Then we'll plunge right into the extreme forces it has to put up with. After that, we'll see how engineers create perfection, how they're learning to predict the future, and finally, where this amazing technology is heading next.
First things first, let's solve that little puzzle I just gave you. The answer, it turns out, lies in the elegant and absolutely essential task of turning power around a corner.
And the answer is the bevel gear. It's this brilliant little device that takes power from an engine spinning in one direction and just perfectly translates it 90 degrees to drive wheels or rotor blades or robotic joints. This simple, cone-shaped gear, it's the real unsung workhorse behind countless machines we depend on every single day.
Now here's where it gets really interesting, because every single time these gear teeth mesh, there's a hidden war being waged, a battle against incredible physical forces, all happening on a microscopic scale.
The first enemy is stress. Now, we're not talking about a little pressure here. We're talking about immense forces being focused onto a contact area that can be smaller than the tip of a pin.
You see, this isn't just about simple wear and tear. As researchers like Trung and his team have shown, these insane pressures can literally create tiny cracks below the surface of the steel. And over millions and millions of cycles, those little cracks grow and grow, until bam, a complete tooth fracture and a catastrophic failure.
Okay, the second big challenge is vibration. And this is way more than just an annoying noise. It's the signature of inefficiency and, honestly, impending doom for a high-performance system.
So, what's the crucial point here? It's that perfection is everything. Studies from researchers like Asadi show that if a gear tooth is off by even a few microns, and that is less than the width of a human hair, it can throw the entire system into a state of chaos, generating these wild, unpredictable vibrations that literally shake the machine apart.
And that brings us to the third major challenge, friction. I mean, in a world that is obsessed with efficiency, every single bit of energy that's wasted as heat is a problem that engineers are desperate to solve.
And this chart just brilliantly illustrates the stakes. While 95% efficiency sounds pretty great, research by teams like Mastrone, Kunklee, and Hugh shows us exactly where those last few, precious percentage points, go. They're lost to heat from friction and even from the energy it takes just to splash oil around. And in things like aerospace or electric vehicles, getting back that 5%, that is a massive, massive engineering goal.
So the big question is, how do engineers fight back against all this stress, vibration, and friction? Well, they do it by pursuing an almost unbelievable, obsessive level of precision.
The way we make gears today has been completely revolutionized. The days of simple cutting machines and manual checks are long gone. Today, as you can see in the work by researchers like Chu and Gomez Escudero, it's a whole new world. We're talking computer-controlled 5-axis milling machines, laser-based measurements, and advanced material science that creates a flawless surface from the get-go.
Yeah, the modern process is basically a symphony of technology. It all starts in the virtual world, right? Engineers simulate the exact contact patch of the gear teeth under load. Then, that digital model guides a precision milling machine. After that, the surface gets hardened with these advanced treatments like nitrocarburizing. And finally, every single contour is verified with laser scanners to make sure it matches that digital ideal perfectly.
And this just shows you the incredible depth of the science here. It's not just about the shape. Researchers like Calde, Xu, and Wu are pioneering techniques like freezing gears and cryogenic treatments to align the metal's crystal structure. Get this, they're creating microscopic textures that hold lubricant better, and even creating a super hard metamorphic layer right on the surface to resist wear. Just amazing stuff.
But, making a perfect gear is really only half the battle. The next frontier is knowing exactly when, after millions and millions of cycles, that gear will finally fail. And this is where artificial intelligence comes in.
So what engineers are doing now is using AI to literally listen to machines.
As research from Tayyab and others shows, they train algorithms like artificial neural networks on the sound and vibration data of perfectly healthy gears. The eye learns that unique signature of perfection, and then it can detect the tiniest, most imperceptible change that signals a microscopic crack has just formed.
So the key takeaway here is that this changes everything. For a critical system like a helicopter transmission, which Mu's research focuses on, you just can't afford to wait for a failure. This predictive power allows a total shift. You go from a fail and fix model to a predict and prevent strategy. And that saves money, equipment, and, yeah, potentially lives.
Okay, let's zoom back out for a second. We've gone from the big machine down to the microscopic surface and deep into the digital world of AI. So where does all this incredible science take us next? What's on the horizon?
And this might just be the most mind-bending idea of all. You've got research from Hosono and his team that's exploring the creation of functional bevel gears on a, get this, a molecular scale. I mean, can you imagine nanoscale machines and robots powered by gears literally built from individual molecules? It sounds like pure science fiction, but the basic research is happening as we speak.
And back here in the macro world, innovation is just nonstop. You've got teams like Sunnet et al. Designing entirely new gear tooth shapes we've never seen before, while Wang et al. Are perfecting forging techniques that create a nearly finished gear with minimal machining and waste. We're also seeing automated laser systems for quality control and even AI that can design the optimal gear shape all by itself. The pace is just relentless.
Which really brings us to our final thought, the bevel gear. It taught us how to turn a corner. But the pursuit of perfecting it has pushed the absolute boundaries of material science, manufacturing, and artificial intelligence. So I'll just leave you with this question. As we continue to master motion at these incredible scales, what once impossible challenges will we finally be able to turn a corner on next? Thanks for joining me.